All right, now are you, on the ones that you're recording, are you posting those on the Moodle page or no?
I should be. I probably haven't, but if you remind me, I will do that.
Okay.
Email me if I don't remember to do that. I've got two classes
Will do.
and I keep getting confused. Okay, so I've started off here creating the struct for the node type, right? I'm not going to encapsulate this into a class yet. We will eventually because it's easier. Okay, so I'm just creating this struct with a node type of the int info and then a pointer to another node type called link. Okay, and then in my int main, I'm just creating a struct node type called new node. And for some reason, and I'm going to have to think about why this wasn't working. And
Yeah.
I don't remember why that's an issue. I remember
I got a similar issue when I try to do that on my add to the beginning. Like when I do that, it works fine. But if I do the arrow, it gives me a segmentation fault.
Yeah, and there's a reason that's happening, but I don't remember now. I'll have to look into it before next class. But this certainly works. So I'm setting my new node.info equal to 6. I'm setting my new node.link equal to null. Okay. So I'm starting to create my list here. So again, I'm doing this not efficiently, right? We're just playing around with it. Okay. So I've got a pointer to a node type called head, and I've set head to point to that new node. Okay. So I should be able to, once that's there, to go ahead and create another node and try to link them up, right? But I think because I'm not doing it as a class, I can't rename it or it's going to cause trouble. So I think I would have to do, I'm trying to make a simple example so we don't have to do the whole thing just for today. Into. Okay, then I set that in2.info equal to say 12, in2.link is equal to null. Then I should be able to set head dot link equal to n2. I think. See if that works. Nope, doesn't like link. So now it wants me to use that. Okay, that's very confusing because I used that before, it didn't like. So let's see what it likes about it. Maybe it's because it's a pointer. I don't know. Let's see if that works. Yeah, I'm going to straighten that out in my mind. Now it's unhappy. Okay, so link should be, is that not a pointer? No, that's a node type. That's my problem. So that, the address of that. Does that work? Yeah, that works. Okay, that's pretty cumbersome, but that's the basic idea there. And I should have actually been able to reuse that, right? It shouldn't have mattered because I've already put that into memory. I just have to recreate a new node. And that's the reason we tend to do it in classes and all that. But that should be kind of the idea for us to play around with. Okay. That I'm able to put those things together. So then if this is working correctly, then I should be able to see out. I've got head. Does it want this? Info. Don't know. I have to play around with this to see for sure. Yeah, that worked. Okay, so we're getting it going here. So then head link info should print out the 12. Yeah, okay. So that's kind of the start doing it by hand without functions. but that doesn't make a lot of sense. It makes more sense to go like the book does and create the abstract data type. Okay. So again,
Sorry, use the what type?
to the abstract data type, it makes a class out of it, a linked list type, and then it encapsulates all these functionalities into it. Okay. Which makes them easier to work with. And it uses, the book example uses a first pointer, a last pointer, and a count, which, I mean, that's fine. You can do that. Takes up a little more room, but it does give you some functionality. So instead of a head, there's a first, and then there's also a pointer at the end. You still can't get to the middle, but you can get to the beginning and the end. And you do know how many there are if you keep track of a count. Okay. So then with our little version here, and I have to reallocate a new one, but I probably can use the same name. So let me see if that's correct. So let me see if I were to, I guess, copy all of this stuff. Again, this is a pretty janky way to do this, but so I'm going to redeclare that. It may give me an error when I do that. Let's see. Oh, that's the one. Yeah. It's pretty, because I'm not in a class that destroys itself, I have to do separate variables every time, which is really an inefficient way to do it. But at least gives us an idea that we can work with it without having to do all that overhead. Okay, so now I should have this. This should be, hopefully we have our linked list working now. So to do a simple list out of these, I could say for int I equals 0, less than 3, plus plus should work. Before that, I would have to set, no, I wouldn't do it that way. Let's do, that's the wrong way. I'm going to set current. So I have to create current as a pointer to a node type. So I have a node type current. I can set current equal to head. So now it points to the beginning. Okay. Then I can have while current not equal null, maybe. I may have to streamline that. We're not in Python, so we've got to put the parentheses around it. Okay, then I can see out current info. And then I can set current equal to current link. That may work, it may blow up. We'll see. It blew up. Why did it blow up?
Was it the cout in your while? In the while loop?
Now, that should be okay. Yeah, I don't know what it doesn't like about that. Oh, okay, so no, it should be okay because current is a pointer. That's okay. That's why this didn't work. This is not a pointer, so this has to have the dot. That's why that didn't work, and why this did work. So that's a pointer. Okay. So the first time through, current should be a valid address at this point, and current info should be something I can print. Wonder if I can't do it in a C outline. What if I need to say int x, say x is equal to, I shouldn't have to do this, but let's see if this is a problem. Current info. It doesn't like that. Oh, that wasn't the first error. Okay. Let's look at the first error. See, if you look at the last error, you're doomed to have trouble. Oh. Well, that was easy. See what the issue is? No one caught me. My C out had the arrows going the wrong way. There could be other issues. I wonder if that works. Now. Nope, still don't like it. Okay. Expected primary expression before that token. Is that going the right way?
I was going to say, is your arrow messed up, Dan?
I've lost my damn mind.
What I love about you, you're just so personable.
Yeah, if you could hear programmers programming, you'd hear a lot of interesting things. Yeah, that was it. That, good Lord. Which means I could have made it not all that craziness, which made no sense. Get rid of that.
Just blame it on dyslexia and you're good.
I actually am dyslexic every now and again, in very strange ways.
That seems to be common.
Yeah, they say people that are mathematically inclined often are dyslexic. I'm not like enough to affect my reading, but I will sometimes write a whole sentence or a whole word backwards, just randomly. And I couldn't do it if I tried, but sometimes I do it without trying.
I'm one of those, like, I could write every letter of the alphabet forwards and backwards and upside down and no issues with it whatsoever. And people's like, how do you do that? My brain just works that way.
I got a weird brain. We all got a weird brain. Some are weird useful, some are weird not useful. But hey, what do you do? There we go. Okay. And I'm not printing that last one because I'd have to tweak it, but you get the basic idea. No, what did I print? I didn't print the first one. That's weird. It should be 6/12/22. It's hard to say what I could have done on this program since I did it real quick. It did a 6. Oh, it missed the middle one. Don't you love when it does that? That's like the least likely thing. That means I've got something wrong on my second node. Let's see what I did. Okay, so I created my first node. Okay, and
Can
head
you
to that.
be in 3 at the same time?
Can I do what?
Can you move your screen down so that we can see all of N3 at the same time?
I can. Oh, yeah. Here's my problem. I set head link to 2. This should be head link link, which is why we use functions, because it's really ugly. Or I could have used a current to get there, but that was the issue. Now it should be good. I wasn't creating a list of 3. I was creating a list of just 2. That worked. Okay. So again, I created one node, and then I was putting the head link to that node, create another node, and putting head link to that same node. So I had to do a head link link to that node, and then it worked. Okay. So this is the kind of thing I wanted you working on now, because again, it's not efficient, but just to get a feel for how this is going to work, and just to make clear my initial confusion. I can't do the dot here because this is not a memory address. It's just a struct. Okay. So that's why I had to do that there. But this one, head is a pointer, so I can do the redirection or whatever that symbol tends to be called to get to that. Okay. So again, that's a weird way to do things, but that's the basic idea. Are there questions about what I've done, how that works, what's really happening? why it's happening.
And you like the structured node type over the class type?
No, not necessarily. I think that the classes work well, but there's more overhead. I wanted to make, I mean, the example in the book's really long, and I think you can lose the detail. So I wanted us to be able to get our hands on it and physically manipulate it in ways that making it more efficient wouldn't allow us.
Okay.
So this is not a good approach, what I'm doing. This is for instructive purposes, not for doing homework or doing real programs.
Okay.
Making it an abstract data type is definitely the way to go. Okay.
Are we going to go over the abstract data type? How to?
Well, we talked about it a little bit before. We can talk about what the book has. I've got that whole thing, I think, in my directory. Let's see. So, yeah, we can take a look at this because this makes a lot more sense. And this is the book code that I've copied over at some point. Okay, so this one's going to use our if not to make sure we don't load this more than once. This is a .h file. Okay, this is the one that's in the book. In fact, this is the two things in the book. This starts off with our struct again. Don't forget your little semicolon there. Those are always annoying, but they got to be there. Okay, and then this is all that iterator stuff. So let's skip down. I don't know why I put that on top. Skip down to the actual linked list stuff. So here's what the book has for its linked list. Okay. So again, this is an abstract class. It has virtual functions. So you would have to derive a class from this. You'd have to inherit from this. Okay. So that's why it's an abstract data type. Okay. So you can't create an object of this. You have to create a subclass. Okay. But it's going to be templated. There's no reason not to template stuff. So you can make it whatever type that you want. Okay. So for its, because we're storing memory data, we're going to do those things we always have to do. We're going to overload the assignment operator here. Okay, they also add later on the destructor and some other things. So, and notice that in their particular version of this, well, it's back at the beginning, so I'm not going to look at it. We have instead of a root or a root or head, there's a first points to the first node, a last points to the last node, and then it keeps track of a count. So you can do whatever you want in your nodes. Okay.
I guess my question is more along the lines of the template stuff. So it has to have that. I can't think what they're called, like the last centigrade or science. That type.
Yeah.
Yeah, all the way down to where it eventually gets to type, right?
Yeah. Every time you do a new function, you got to put another one of these template class types.
I guess
then you can use it inside of there because you'll see that more than once.
All right.
So maybe you don't. I think we see it in the other one as well. I guess it depends on how you put those together. Yeah, it's down here again. Yeah, here's where when it's defined, when it's not in the prototype, when it's actually defining it, you see it puts that every time. Okay, and again. Okay. Just to review, what that means is, so we have to send it something. We can't just leave it as type. That type will evaluate to an int or a double or a float. Okay, and then we use it wherever we need to use it when we're declaring things. Okay.
I guess like the question, can you go all the way back up to the top where it defines the struct?
I don't know how to get all the way to the top. I need to look that up. I have to get the beginning and end of a file. I'm sure there's a way. I just don't do that apparently. Sometimes in viewing the code like this, you kind of see things that look out of place. So I guess that's why I haven't learned the other way. Yeah, right here.
So it has to have the angle brackets type on that node type link just to tell it what type's being sent to it, right?
Yeah. Now, again, you could just make that int and you wouldn't have to worry about it if you wanted to do that, but you don't want to do that. You want to leave it this way.
Okay.
So does that part have to be before before everything? Like that's not a completely different file itself?
It could be, and you could include it, but you don't have to.
Okay, cool. So I'm definitely going to add that.
Yeah, it does need to be before, because you're going to use node type and it's going to tell you it doesn't know what node type is. It'll say node type not declared in this scope.
I actually have a question about something I wrote for the assignment.
Okay. Do you want to share screen? Let me see if I can
Yeah.
make that possible. Should be able to now.
All right, good. It still works. Here. So when I just have it as the regular node, not the pointer,
Right.
this works. But if I change this to a pointer and all these to the arrow, it gives me that segmentation fault. And I'm not exactly sure why.
That is strange. And I think the problem is when you make that a pointer, it's not allocating the memory for a new object.
Hey, Dylan, for learning purposes, do you care to change those to the arrows and let me see the error that you're getting, please?
Yeah. Yeah, it spits out the list originally, but
yeah,
it does the segment.
Yeah, I think it's because we're not using a new keyword somewhere. You have to allocate that memory, and it's not ever being allocated.
Yeah, so I'd have to do it like I did here, just the new node.
That's 100% what you have to do. That's it. That's the new. Yeah, the new is what.
All right.
They call that a segmentation fault.
Segmentation. Yeah, segmentation fault means that you're accessing memory outside of your authorized box to have memory.
All right. Yeah. And then that brings me to the question of, I know this is a memory leak because I never get rid of all of these nodes, right?
Yes.
So how do I do that?
Well,
Do I
yes.
have to go through each individually, or
only the things you're doing on the new, right? Because if you when you add them into the linked list, let me think. If and it's because you're not doing it in a function. Because if you're doing it in a function, then it's going to delete when it closes the function. But because if not, anything that you've done with a new, when you're done with it, you'd have to erase it with a. So you need probably, you don't have a class, you can't have a destructor. But yeah, at the end of your code, new node, you've got a new, so you have to do a delete new node, and you have to do a delete node as well. Whenever you have add. New node and add would both have to be deleted.
So this for loop goes through 5 times, but after would just deleting new node kill all 5 of those?
Yes, should. Yes.
All right. Okay.
And again, this is a weird way to do it. It's not the most logical fashion. So what the book does with the class and the abstract data type is definitely the way to go. And then you would, when you write a program on this, you would have to, and that's the next thing the book does, an unordered and an ordered linked list, it's going to pull in the abstract data type. And then it's going to make an implementation of that and fix those virtual functions that it has with real functions. That's weird. It must be gone already for some reason.
Yeah.
Yeah. If you tried, you don't. Then you didn't have to. If you tried, it won't let you. Then you didn't need to.
Just make sure I actually spelled new node right.
Well, I guess because you made a pointer rather than making a new node, you didn't really mark that memory as used. You created, in essence, a dynamic variable that doesn't really have any name. there's no node there. There's a pointer to an address that it allocates.
Yeah.
But it's not really a thing. I think that's the issue. Yeah, it's weird. Yeah, you will find that you can get yourself tied in knots pretty quickly with these new structures. Okay. So I've got the homework out there for chapter 5. I forget which ones that I did, but they're on Moodle. I don't think I marked them in the book this time, which is weird. So what I would do, I would read through the rest of the chapter when it explains its abstract data type and how they're going to use it. And we'll go over that. We're out of time today, so we'll go over that more tomorrow. Okay, that code starts on, well, it does an example of it in the ordered list type on page 308 using that linked list.h that it creates. Okay, so that's going to be where it actually derives a real example. So that example should be kind of like what, that should be a full working example. So if you type in the linked list.h and you type in the ordered linked list type, that should get you something you can actually do something with. And then there's a test program on page 309 and the output of that. Okay. So it also talks about doubly linked lists, which go forward and backwards. And it talks about circular linked lists, and it talks about, lots of other variants there. Okay. So read through the rest of the chapter. We're going to skip that standard template library on list. It's just not enough to worry about. You can look at it if you want, but not something we're going to dwell on. But then there's a big example on a video store. Again, those programming examples are useful. Let's see if I've marked which homework problem from this chapter we're supposed to do. Let's see. I think it's the splitting the list into 2 sub lists. I think that's what it does. So I think it's 5 maybe, or I don't know. I don't remember, but it's one. There's not a lot of homework, I don't think. But go ahead and either type in or cut and paste that linked list .h and see if you can get that working and understand what's going on with it, at least in part. And we'll start there tomorrow, going through that in greater detail. Okay. Does that make sense?
Yeah. So just the abstract data type for the linked list is basically just creating all of the functionality we could possibly use for it, rather than us having to do
all the
what
crap
we did.
Yeah. Yeah, all the crap that we did because we didn't want to do the whole big job was going to be made easier once we have that abstract data type. Okay. But I wanted us to play around with this to get a better feel for what's happening. So I think that it will make more sense looking at that big abstract data type once, now that we've seen this. So that's what we will start tomorrow. Okay. Are there other questions? Okay, well, I will see you guys tomorrow then.
All right.